Hey everybody, this is 2.4D. We're going to be looking at some word problems with slope and y-intercept. So we're going to need to remember that to find slope we need the change in y over the change in x. So y is on top, x on the bottom. And the y-intercept is going to happen at that y value whenever x equals 0. And once we have those two bits of information, we can plug them into slope-intercept form and make an equation. So our first problem or example says Karen rented a bike, and after the second day it cost her $19. So that's going to be important. And after the sixth day it cost her $47. And we want to know the rate of change for renting the bike each day. So what I would do first is make a table, just like we've been doing, to find rate of change. And we're going to put our x values on the left, so our days. So on day 2 it cost her $19. So 19 will be my y. And then on the sixth day, it cost her $47. And then we can just find our change in y over change in x to figure out that slope. So for change in y, we're going to do 47 minus 19, which is 28. And then for change in x, we're going to do 6 minus 2, which is 4. So remember that change in y goes on top, change in x goes on the bottom, and that is going to simplify to 7. So that means our slope is going to be 7. Then if we want to find our initial cost, so I'm just going to take my table that I have over here, and I'm going to bring it down, and we're going to just work backwards here. So we've got our table. We know that our x values are 2 and 6, our y's are 9 and 14. And we want to figure out where x equals 0. And I know that for each x value, we're changing by 7 on the y column because we already figured out our slope is 7. So if I'm working backwards here, if I subtract 1, I'm going to subtract 7 over here. So that's going to give me 1 and 12. Well, I want where x is 0, so I'm going to subtract 1 again, and I'm going to subtract 7 again. And that tells me that when x is 0, y is 5. So my y-intercept is going to be 5. And then it says, write the equation to model the situation. Well, we know that our slope is 7 and our y-intercept is 5. So we've got y equals 7x plus 5. Now it says find the total cost after a full week. Well, there's 7 days in a week, so I'm going to plug that 7 in for x. So y equals 7 times 7 plus 5. And if we simplify that, that's going to give us 49 plus 5, which is $54 for a week. The next example says during the summer, swimming pools lose water due to evaporation, which means water must be added back to the pool. At 9 p.m., the amount of water is 422 gallons. At midnight, there are 530 gallons. What's the rate of change for the number of gallons being added each hour? So rate of change means we're finding the slope. So we are going to go over here and make a table out of those values. So our x's are going to be our time. So we've got 9 and midnight. We know that midnight's at 12 a.m., so we're going to put a 12 there. And our y's are going to be our gallons, so 422 and 530. And then we're just going to have to find our change in y over change in x. So we're going to do 530 minus 422, which gives us plus 108. And 12 minus 3 gives us plus 3. So our slope is going to be change in y over change in x, which gives us 36. So our slope is 36. Then it says how many gallons of water were in the pool before water was added. So that's like our starting value or our initial amount of gallons. So once again, I'm going to take my table and I'm going to apply the same rules backwards. Okay, so I want to get to a point where my x is 0. So if I was adding 3 before, I'm going to subtract 3 this time. I'm going to subtract 108 this time. So 422 minus 108 gets us to 314. And we're just going to keep on going until we get to 0. So we'll subtract 3 again, brings us to 3. We'll subtract 108, brings us to 206. And one more time, if we subtract 3, that gets us to 0. And subtract 108 one more time, that gets us to 98. So our y-intercept is 98. And if we put that into an equation, it's just going to be y equals our slope of 36, x, plus our y-intercept of 98. And then it says if water was continually added at the same rate, how much water would be in the pool at 2 a.m.? Well, at 2 a.m., that is going to be 5 hours more than our initial value. So from 9 o'clock to 2 o'clock, that's 5 hours past that. So I would say 9 to 10 is 1 hour, 10 to 11 is an hour, 11 to 12, 12 to 1, 1 to 2. So we're going to plug in 5 for x. So we're going to say y equals 36 times 5 plus 98. And we'll just simplify that. So 36 times 5 plus 98 gives us 278. So it would be 278 gallons at 2 a.m. Actually, that is not right. So we shouldn't be plugging in 5. We're actually going to plug in 14 because 2 is coming 2 hours after midnight. My bad there. So if we plug in 14, we'll do 14 times 36 plus 98, and that gives me 602. And guys, if you get to an answer like that, so last time I said it was 278, and I looked at my table over here and I said, hey, that doesn't make sense, okay, because at 3 p.m. we were at 206, okay, and at 6 p.m. we were at 314, 9 p.m. we were at 422, so we're increasing. So 2 a.m. comes after 12 a.m., so I must have made a mistake there. So make sure you check in to make sure your answers make sense. So 2 a.m. is 2 hours after midnight, so we're just going to add 2 to 12. Our third example is a little bit different. So we've got some dots. So in figure 1, we've got 1 dot. Figure 2, we've got 3 dots. Figure 3, we've got 5 dots. So assuming the pattern continues, how many dots will there be in figure 5? Well, we're just adding 2 every time. So if I add 2 to figure 4, we had 1, 2, 3, 4, 5, 6, 7. So we should have 9 dots in figure 5 if we continue that pattern. What is the rate at which the dots are changing? So we know that that rate of change, or that slope, is 2, because we're increasing by 2 every time. But if we weren't sure, we could make a table. So we could say that in figure 1, we have 1 dot. In figure 2, we have 3 dots. In figure 3, we have 5 dots. And then we could see very easily that that's a slope of 2 over 1. But then it says write an equation to represent the number of dots that would be in figure X. To do that, we got to find our y-intercept. So I'm going to work backwards. So I'm going to subtract 1, and I'm going to subtract 2. So that's going to give us our y value when x is 0. So 1 minus 2 is negative 1. So that tells us our y-intercept is negative 1. So our equation would be y equals 2x minus 1. Alright, last example, guys. A bird is rising in the air. The height of the bird at 2 minutes was 640 inches. The height of the bird after 5 minutes is 930 inches. The bird continues to rise at the same rate. What is the height of the bird at 8 minutes? So we're going to need our slope and y-intercept so that we can plug in that x of 8 and solve. So we're going to make a table. So our x's and y's. Our x's are always time, so 2 and 5. And then y is going to be our inches, 640 and 930. We'll find our change in y over change in x, so 930 minus 640. 930 minus 640 is 290. And 5 minus 2 is 3. So 290 divided by 3. So 290 over 3 gives us 96.6. Alright, that's our slope. And then if we want to work backwards and find our y-intercept, we can do that. And notice, so we're adding 3 here, so we can't subtract 3 because that's not going to take us to 0. So I'm going to subtract 1, and I'm going to use my slope value so that I know that it's per each x value instead of per 3 x values. So I'll subtract 1, and then I'll subtract 96.6, so that brings us to 1, and 640 minus 96.6 is 543.4. Then we'll go one more time to 0, we'll subtract 1, and we'll subtract 96.6, which gives us 446.8. So that's going to be our y-intercept. So our equation is y equals 96.6x plus 446.8. And we want to find the height after 8 minutes, so we're going to plug that in for x. So 96.6 times 8 plus 446.8. So let's plug that in to our calculator. And that's going to give us y equals 1,219.6 inches after 8 minutes.